Hi everyone, Mrs. Gress here. I'm going to be going over some stoichiometry problems with you. And I just want to explain to you a little bit, maybe an analogy of what stoichiometry actually is. Stoichiometry is kind of like baking. So I want to know if I have a recipe that includes flour, milk, sugar, and eggs, um, how much, let's say, cake or cookies or whatever I can actually make from all of the ingredients that I have. So some of you may actually be running into, sorry, water bottle. Some of you may be running into that now that you're home on quarantine and you're like, okay, I got this much flour, I have this much milk, I have this much eggs. What can I make and how much can I make of it? So what we're trying to figure out here is kind of how much of what do we need to make our final products in a equation. So you're going to start with reactants and we're going to finish with products. So if we have if we know that we're starting out with 1.3 moles of water, and I want to know, okay, if I'm starting out with water, my equation is going to have to do with water. So the question I'm going to pose to you is how many moles of oxygen am I going to need then? Or how many moles of oxygen can I get if I have 1.3 moles of water? So the first step is to balance an equation. So normally it'll be given to you, but sometimes you're going to have to write it out. So we have water, and water is our only reactant. We have hydrogen, and we have oxygen. Now, remember that this equation is not balanced. So the first thing that you need to do is balance the equation. So if I balance this equation, there is two H2Os, and there's two hydrogen molecules, and then there's one oxygen molecule. So what this is saying, it's giving you a ratio. So for every two water molecules, I'm going to have one oxygen molecule and two hydrogen molecules. This is all based off of the law of conservation of mass, that what you have at the beginning is what you need at the end. So I don't have 2 moles of water, I only have 1.3 moles of water. So how many moles is that going to give me at the end? Well, you are just giving yourself a ratio by just balancing out the equation. So start with what you have, like I always say, 1.3 moles of water on the top, and then I need to cancel out that mole of water, so I'm going to put moles of water on the bottom, and I want to get 2 moles of oxygen. And this number, this coefficient in the front, tells you the number of moles. It represents the number of moles. So I can actually go to moles of oxygen here. So the numbers that fill in here and here come directly from your balanced equation. So the number 2 goes with my water, because I have 2 moles of water to every 1 mole of oxygen. So that's how I set it up. So my moles of water cancel out, my moles of water cancel out. I'm left with my moles of oxygen. So what I have is 1.3 times 1, which is itself, divided by 2. And I am going to get 0.65 moles of oxygen. So that's how you do a mole-to-mole problem. First step is you have to write and balance your equation. Second step is to write out your conversion factor using those coefficients as your number of moles that go right here in your kind of setup. And then finally is to actually get your answer. Another problem would be sticking with that same equation. What if I start with 1.3 moles of water, and I want to know how many grams of oxygen I'm going to get? Okay, so first thing, if you are given or asking for grams of a specific molecule, you're going to have to figure out either the formula mass or the atomic mass of that molecule or compound. So before I even get started here, I'm going to say, okay, O2. The formula mass of O2, there's 2 oxygens. Oxygen is 15.996 7, I believe. It's around 16, 32 grams, okay? So the formula mass of oxygen is 32 grams. So setting this up again, we have water, hydrogen, and oxygen. Sorry. Again, we have the same moles that go on the front. So there's 2 waters to 2 hydrogens to 1 oxygen. That's our ratio for our moles. So the setup goes exactly the same, only we're going to go one step further. So we start with 1.3 moles of water. I need to cancel out moles of water, so I'm going to put moles of water down here on the bottom. And because I'm trying to get to oxygen here, the only way that I can get to oxygen is to go through moles first, because I know how many moles of water I have to how many moles of oxygen I have. So I'm going to put moles of oxygen. I'm going to change colors here. Moles of oxygen goes on the top. I don't want to stay at moles of oxygen. I need to get to grams of oxygen. So you can use your conversion factor of 1 mole is equal to the formula mass in grams of that formula. So I can put moles of oxygen down here. Whoops. Oh, sorry. O2. And then I can put grams of oxygen up here. Now notice I'm doing O2, not just O. If it would give you, say, let's say a metal like silver, you would just use silver. If it has a 2 with it, okay, you have to multiply that atomic mass by 2 because you have 2 atoms. So again, that's the whole reason why I did that, was to put it down here. So 32 grams goes there. Because I have my conversion factor of 1 mole is equal to the atomic mass or the formula mass, 1 goes down here. And then my coefficients from the equation, again, go in my mole to mole problem. So 1 mole of oxygen goes here, and then 2 moles of water goes there. Now, I can cancel out my moles of water. I can cancel out my moles of oxygen, and I'm left with my grams of oxygen. 41.6 divided by 2 is equal to 20.8 grams of oxygen. So that's kind of in between step. The next one I'm going to go over with you is a mass to mass problem. So this one is like one of the longest ones that we have because it's a mass to mass, but we're going to set it up exactly the same way that we did these other ones. Only instead of starting with moles of water, I'm going to start with grams of water. So I don't know, let's say one of my favorite numbers right now is 28. So let's start with 28 grams of water. And I want to know how many grams of oxygen it's going to create if I start with that. So again, I start with my equation, H2O, H2 plus O2. I'm going to put my coefficients up here so I can do my mole to mole calculation. There's my ratio for that. And I'm going to start with what I have. So I'm going to start with 28 grams of water. And I need to cancel that out with grams of water down here. The only way that I can get 2 moles of water to use my ratio is to go from grams to moles. So I'm going to go from grams of water to moles of water. Then I'm going to need to cancel out my moles of water and do my mole to mole conversion. Moles of H2O to moles of oxygen. And then sorry, I ran out of space there. It's going to be moles of oxygen on the bottom and grams of oxygen on the top. So from the last question, we figured out that the formula mass of O2 is approximately 32 grams. From our balanced equation, we know that the 2 goes down here with the H2O moles, and the 1 goes with the moles of O2. The last thing that we need to figure out is, what is the formula mass of H2O? Hydrogen is 1. Atomic mass is about 1. times 2, which is going to give you 2 grams, okay? And then 2 grams plus 16, because that's oxygen's atomic mass, is going to give you 18. So the formula mass of water is approximately 18 grams. Now remember, this is 16 times 1, okay, which is equal to 16, all right? So 18 grams goes here, and remember, 1 mole of any substance is equal to its atomic mass or its formula mass. So 1 mole goes up here. So now I just need to calculate. 28 times 32, which is going to give me 896 divided by 18 times 2, which is 36. 896 divided by 36 is equal to 24.89 grams of O2. That is going to be my final answer. Can cancel out my grams of water, cancel out my moles of water, cancel out my moles of oxygen. Whoops, sorry, a 1 is supposed to go down here. And then I'm left with my grams of oxygen. So I know that was a whirlwind, but I hope it helps you understand how to set these up, and that when you're setting these up, you're just tacking on to a mole to mole conversion. I hope this helps, and of course, if you need any more help, please let me know. See you later.